So we didn't quite get a chance to finish problem number 6, so we're going to be doing that right now. So is everybody in the same place as me with your notes? Yes? Yes? Okay. So we were in the process of graphing the cube root of x minus 1, and we said we were going to move that to the right 1 to start my cube root function. And we said the cube root of 1 is 1. What's the cube root of negative 1? Negative 1. What's the next number that has a nice cube root? Negative 8, because 2 doesn't have it. Everyone always flips those around. And you want to make sure you're really careful about that. 1, 2, 3, 4, 5, 6, 7, 8. And down 2. One of the things, again, that I use to kind of help make sure that I'm doing the right parent function for this is I use the function itself as a hint. This one kind of goes whoop, doot, doot, out. So that means my function will go out. Rather than a cube like this, if you have to reach up to grab that sign, your graph should be skyrocketing up as well. So try to use that as a hint, because cube and cube roots are usually the most missed functions, simply because people get them switched around. So use the appearance of the function as a little bit of a clue to you. All right, but let's finish this off. We need to talk about f of 2. What is f of 2? Say it again for me, Theo. Why not? Because they're open circles. This function is not defined at 2. So if I look at this, I have greater than and I have less than, but I don't have equal to anymore. So this guy does not exist. Do not tell me undefined. Okay? Doesn't exist. It's not in my function. Now, f of 10, we've got a little bit of a problem, because if I want to do 10, I got to come all the way out here, which would then shoot all the way up. And yeah, that's not on my graph. So any suggestions what I can do to evaluate f of 10? Yes, ma'am. Plug it into the top one? Why the top one? Because 10 is greater than 2, I'm going to put it in the top one, correct. So it's 3 times the absolute value of 10 minus 2 minus 1. What is 10 minus 2? Absolute value of that, 8 times 3, 24 minus 1. Boom, shakalaka, and you're done. Now, as I look at this graph a little bit closer, because I personally think domain and range is a lot easier to do looking at a graph if you can. Domain. Does it go all the way to the left? Yeah? Does it go all the way to the right? Is it everywhere in between? No. Where is it not? 2. So you can either write x such that x isn't 2, or for my interval notation folks in here, I would go from negative infinity to to positive 2. Boop, there we go. Union 2 to infinity. And please, 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 always, always, always go from negative to positive, small to big. If you flip that around, it's wrong. The range. Does this graph go all the way down? Yes, because this little arrow here isn't just pointing straight left. Pointing left and down at the same time. So it's going to take it a long while to get down there, but it will eventually get down there. We'll go all the way to the top. Yeah. We'll go everywhere in between. Yes, because even though we have open circles, this open circle is also filled by that spot right there. And this open circle has got a spot on it right there. So this is, again, all real numbers. Or negative infinity to infinity. And beyond. All right, let's do this one together. Actually, no. I want you guys to see if you can graph those on your own. So you go ahead and graph, I'll go ahead and graph, and we'll see if we meet in the middle. And I want you guys to check your answers with your neighbor. It helps wake us up a little bit too. Oh, and please change. I don't believe that's the same thing that's on your worksheet, is it? Take a look. Is yours a positive 2 or negative 2? Change it to a negative 2 You can't really graph it if they're positive 2's. Change both of them, please. Yes. Again, check with your neighbor. The tricky part about these is graphing the parent functions. Yes, I'm blowing up my printer. It's just hot water boiling. I forgot I haven't done that to you guys yet, have I? It's like, oh my God, we're gonna die. Please check your answers with your neighbor. It's so quiet in here. Stop being so quiet. There we go. That makes me happy. Okay, so let's go over this then. I have to find the pause button. Here we go. So a couple of unsatisfied uggings. Ugh. What color, blue or pink, 3 off? Snimmer her? Blue? Trying to figure out where that voice was coming from. Okay, thank you. I was like, if I don't see it, I don't know. I'd like to know who I'm talking to. All right, so let's just kind of start by sketching out what the parent function would be. So I've shifted it up 3, and the square root, what's the square root of 1? 1. Square root of 2? There isn't a nice one. There is one, but it's ugly. What's the next number that has a nice square root? 4. 1, 2, 3, 4. And that square root is 2. So this is what that parent function normally does. A negative on the inside is going to flip it over which axis? Over the y. It's going to go whoop like that. So instead of going that way, I go left 1, up 1, left 4, up 2. And the weird thing about this graph is I don't want to see it at a nice point. I don't start seeing it until -2. So wherever that guy is, I just draw an open circle. And sometimes what I'll do is if it's kind of hard to understand what's going on, I'll draw it, put an open circle on the number I want, and then erase the rest of it. Because I think that makes life a whole lot easier.
If it's easier to do that,
Mm-hmm.
I just feel like if I start like naming them under that, I'm not going to have time to do that. Is that going to be a problem?
No, it shouldn't be. That really shouldn't matter. Just make sure you erase the parts that you don't want. Michaela.
So, do you just treat
Which one are you looking at? The pink one? Both of them. So for this guy here, I just started up 3. And then I did my square root function over this direction. Okay. For the cube root is kind of harder to see because between -1 and 1, it looks pretty much just like a line. What I did for this one, I said I moved it left 1 and up 2. So that's my starting point for a cube function. Then I said 1 cubed is 1. 2 cubed, and again, it's reaching up, so it's going to go up. 2 cubed is actually 8, so I'm off the graph. So I'm not going to cross that line quite yet. Okay, and then I did -1 cubed is -1. Okay, so I've moved my axis to right here. Okay. Did you guys get your domain, range, and functions evaluated at? All we're doing with this is practicing. The only thing that I can do to make this harder is just what I'm doing, giving you trickier parent functions to graph. Okay. Well, let's take a look at some more. I want you guys to do for me, please. Let's do 8 and 9. Why don't you guys work through problem numbers 8 and 9 for me? Please don't forget, I'm not asking you to do domain and range here, but you do have to evaluate the functions. Okay. So when we're looking at this, it helps if I unpause it. Let's take a look at the first graph. First problem right there. Make that go away. Okay. Questions on that? Interesting thing that I noticed on the quiz, a couple of folks need to pay attention that those are just the straight lines, and when you don't have any of the tops or the bottoms, this is just a V, whereas the other one is the absolute value. I did have some folks mixing that up a little bit. And it's just a matter of kind of slowing down and taking a look at the problem. Seriously, questions? I don't expect everybody to have this yet. Yes, sir. Yes, I'm sorry, thank you. Positive one. There you go, finding all my mistakes. Gosh. It's like, you're a teacher, you're not supposed to make mistakes. But I'm human. Last I checked. Seriously, any other questions on that one? That 2 to the x graph okay? 2 to the 0 is 1. 2 to the first power is 2. Okay, and we got our, yes ma'am.
Why do you have it as -1.5? It's halfway up.
Because when I go 2 to the -1, that's 1/2. Okay. All right, let's take a look at the other one. Take a look at that real closely, please. You'll notice here when I graph the log function, it really is just the entire log function because that 1 is my asymptote. Yes, sir. Could you repeat that for me, please? See, I'm paying too close attention to numbers and I'm screwing up on my signs. Ugh! Like I said, I didn't want to come to school today, so I left part of my brain at home. You've never known what that was like, right? My body's here, but my brain isn't. Those are my biggest mistakes. I know exactly what I'm doing, and yet I miss up on the little things all the time. Yes, sir. No, it wouldn't, because... Oh, wait. Yes, I'm sorry. Thank you. Good catch. Because for this one, we get stuck at doing our step functions. My next dot would be right here. And that's because this function actually includes what happens at 1. You just don't finish it. Because that, like, if I were to continue graphing that step, I would go back and I would erase anything bigger than 1 anyways. So that's all I can see there. No, it would be, because if we keep following our pattern here, closed up 1, over 1, close, 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 close. So this is going to be closed. It would be open over here. But then I would erase everything that is not in my domain. So I would go back and I would erase this stuff because it's greater than 1. Do you understand what I'm talking about? So here is 1, and then I wouldn't want anything over there. Okay, you guys are, I have some on-the-ball students in here. Good questions. How did our log graph go this time? Some folks a little bit better? Okay. Nice thing about the piecewise is it gives us more time to practice these parent functions. Okay, so we've got 2 more of these problems. I want you guys to do number 10. Try to do number 10. And then we will come back and take a look at that, and then we'll do number 11. So if you finish 10, go on ahead and do number 11. Jeez is right. It's like there's... All right, so here's your graph. Let me pull that out just a little bit. So basically all I did was I started by graphing this guy, but I only cared where it was less than -3. So I only graphed the part that I could see from here. And so that meant I moved it left 3. That was my new start. And I said 2 divided by -1 is -2. 2 divided by -2 is 2 divided by -2 is -1. And then I said 2 divided by 1/2 is 4. 2 divided by 4 is 1/2. Yes? That's supposed to be open. It's hard to tell because I put the plus sign there for the other function. That is open though. So thank you for asking that. Yes, sir. Okay, so I'm going to ignore everything else that I have here. Right? That -3, what does that do to my graph? So I'm going to go 1, 2, 3, and I've got a little starting spot right there. And then I'm going to think about this in terms of 2 to the y equals x, because that's a 2. What is 2 to the 0 power? 1. So that means I don't go up and down at all. My y is 0. I go over 1. What is 2 to the first power? 2. So I go, now you see? Okay. Okay. Okay, how so? Yes, because if I were to have graphed the other portion of this, if I would have said 2 over 1 would have been 2, would have been here. This would have come out here. I know, I'm going to get to it in a second. Do you understand what I'm talking about, though? That part is not less than -3, so I didn't graph it. So make it go. Okay, Michaela. Because in goes y, out comes x. Because it's backwards for logs. So 2 to the first power is 2. I put in y was 1. X was 2. Okay, the logs are very hard to kind of think, otherwise you're going to be trying to memorize things. Instead, it's easier to do this, rewrite it in its inverse, and graph that function, just switching your x's and y's around. Okay? Now I think this one, next one's the doozy. We've got step, we've got absolute value, and we've got exponents, and we've got negatives. And the negatives, I think, are going to cause the most trouble. So please, 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 work together if you need to. I want you guys picking each other's brains. Your neighbor might be able to say this in a way that's different than the way I've been saying it. And maybe that'll help you. Okay? So go ahead and do number 11 for me, please. All right. So that is what your graph should have looked like. Let's take a good look at that one. I'm going to zoom it in nice and big for you. One of the biggest things that I've seen folks messing up with this on is they're using these numbers as if they affect where your graph starts or ends or anything like that. The only thing that this affects is what you see, what's actually on the page. It doesn't affect where my parent graph starts or moves to or anything like that. This parent function says, hey, move it over left 3. So I go 1, 2, 3, and it goes down 2, out 1, down 2, out 1. Okay? And then the only thing that this does to my graph is it says, I only want to see this in that portion. I don't want to continue seeing that graph anywhere else. That's all that these guys do. They do not affect where your graph shifts to or anything like that. It just says I'm going to chop it, and I'm only going to see this part of it. The rest of it goes away into the trash. Okay? Questions? No, it's okay. Which color? The exponential one? Okay. So for the exponential function, if I were to graph the parent function for that, I don't have to move it left, right, anything like that. I would say 2 to the 0 is 1. 2 to the first power is 2 to the second power is 4. And I wouldn't want to go any further past that. 2 to the negative 1 would be 1/2 and then 1/4. But a negative, and you see how that negative is up. It's up with the little stuff. Is that inside or outside? Inside. And so inside is going to move it left to right, so reflecting over the y-axis, which is how I end up with this last piece. Okay. Any other questions on this? Yes, sir. Uh-huh. No, it's a little bit above, but it's hard for me to kind of like show that. So I was trying to get it there. It's just when it's that close, it's very difficult to kind of tell. As long as you're open, I'll pretty much know what you're dealing with. Yes, Theo. Right, because inside, you do the opposite. So if it's saying times by 1/2, I'm instead going to times by 2. Okay? All right. So, do. 1 second. Go ahead and pull out your homework for me, please. I want you to look through front and back, and I want you to find which problem do you think was the absolute hardest problem on the entire thing. Which one was hard, which means it's probably something you might still have a question on. I know there's a couple really nasty ones out here because I had a lot of people come and ask me. Yes, sir. Probably problem number 10. Okay, let's do problem number 10. If we look at number 10, again, I'm going to break it down into just little pieces. What type of a function is that? No. This is a step function. Just said the wrong one. Yeah. It's like I knew what I was doing. I just said the wrong thing. Welcome to my world. Okay? And where am I going to start that? Where does that function start? Up 1. So I'm going to go up 1. I'm going to completely ignore this thing right here. Now that 1/2, inside or outside? Same or opposite? So what is the opposite of 1/2? 2. Is that going to affect the height or the width? The width. So from here, I'm going to go over 2 and then up 1. And I'm going to go back the other way. So that's going to be open, over 2, down 1 to keep that pattern going the same. Now, I only wanted to see this graph where x was less than 0. So it means I'm not going to include the 0 point in there. That's going to be just like that. and that's that portion of the function. Then I'm going to look at this next one. What kind of a parent function is this? It's another step. Has it moved left, right, up, and down at all? No. So I know I'm going to have a starting point right here. Now, is that -1 inside or outside? Inside. So is that going to affect my height or my width? The width. So my width is going to be -1. So what I would originally do is I would have my closed circle and then an open circle here. And then one negative always looks like it's stepping down. So the next one would be open circle, closed circle, open, closed. Yes, sir. Uh-huh. It is, but the red one fills it in. Because if I were to kind of like, let's make this blue one disappear for a second. Just when I erased it. Gosh! Okay, so then this, now I gotta put them back in the right places. And I did it wrong. See? I had it right the first time. You messed me up. There we go. Ding! It's okay. No apologies. Okay. How are we with that one? Okay, I'm not going to bother with those two because I think you guys are good with that. Give me another one that you thought looked like, oh my God, I'm going to cry. Yes, ma'am. 7. She says with enthusiasm. Thank you for saying 7 because that was the one I had people go, I don't want to do this one. Lots of stuff going on there. So let's just work top down. All right, so let's start with this guy. Where is my function moving? To the left 4. So 1, 2, 3, 4. That's where my new thingy is. And the way I'm going to think about this for my parent function, I'm going to think about that as -1 over x, and I'm just going to do that. Since I don't want this side of it, I only want less than -4, I'm going to go -1. So what is -1 divided by -1? Negative divided by negative is a positive. There you go. What is -1 divided by -2? 1/2. Let's go a little bit closer. What's -1 divided by -1/2? -1 divided by -1/2. First off, negative divided by negative is a 1 divided by 1/2. 2. To divide by a fraction is to multiply by the reciprocal. So it just goes here. And then am I ever going to be able to divide -1 by 0? Nope. So that means that's going to be my asymptote. And it just goes like that. Yes, sir. For this guy, it looks like, you mean this piece was flipped over the x-axis? Then that was a mistake. Okay. That was a mistake then. I usually do my keys really fast, and that's not usually a good idea. All right, let's do the middle piece. What is that dude? That would be an absolute value. Where is he being moved? Up 3. 1, 2, 3. So that's where I'm going to start. And that negative is going to tell me what? Flip. So it's going to flip across the x. It's going to open down. And for absolute value, it's basically just a slope. So, and I want to carry this from -4. That's going to be an open circle. To 4. And that's going to be a closed circle. And then my log function. Where's my log function going to start? to the right 4. So I'm just going to move my little axis over there. And instead of doing this, remember with log, it's much easier to think 2 to the y equals x. So when I put 0 in, that means I'm not moving up or down at all. 2 to the 0 is 1. 2 to the first power is, say it again, 2, thank you. 2 to the negative 1 is 1/2. 2 to the negative 2 is a 4th. So this guy is just going to get really, really smooshy over there. And there's your graph. Okay? All right. So you guys have been working very hard today, and you've been very patient with me. So this is what I'm going to do. Today is what day? I'm going to push your test back to Friday. Okay? So your test is going to be on Friday. What I want you guys to do right now, I want you to finish up your piecewise functions if you have not done so, because we didn't get that much practice done in class. You have your quizzes. If you would like to do corrections, I also gave you a little sheet with graph paper on it. You can do your quiz corrections. Remember, if your score was below a 70, which is I think if you had anything 33 out of 48 or lower, you're required to do corrections. And just to make sure everybody understands, these are separate grades. This doesn't affect your quiz grade at all. These are separate grades that go in as homework grades. And your homework grade will be whatever percent of your corrections you actually corrected. The only time I try to be a little bit nicer than that is the few cases where somebody might miss one problem, go to do a correction and do it wrong. You only made one mistake in the beginning, so I'm not going to give you a 0 on your corrections, but I'll only give you half for that. Okay? But again, you've got to get the corrections correct. That is the point of this activity. Yes, sir?
Only if part of the problem was wrong, like you graphed it or say
if you put a domain and range wrong, I want you to just put one of the graphs, just I want you to write graphed correctly and then restate your domain and range. If your graph has any points missing, you got to redo your graph. And the way I graded your domain and range is as long as your graph had some semblance of the right parent function, even if you graphed it wrong, but the domain and range you stated matched the graph that you had, I gave you the domain and range. If you graphed the wrong parent function, I didn't give you anything. Okay? All right. So you've got two things. You've got this. You've got quiz corrections. And I know some of you guys are just on top of things like it's nobody's business. I do have your test review. Okay? If you would like to look at it, this is all we're going to be doing on Wednesday. Okay? So I don't want you guys going and doing every single problem, because then what are you going to do on Wednesday? But if it's something that you would like to take a look at, do a couple problems here or there, you can. And I'm going to point out to you guys that your reviews are broken down in the same way that our tests are. Okay? So for your review, you will see you'll have graph the following equation. So the first section is about graphing parent function, or graphing with transformations. Then it says find the domain and range. The next piece is about piecewise functions. Okay? Then you have a factoring section, a little bit more with piecewise, and then you have summer assignment review. Your test is going to be broken down into 4 pieces: factoring, transformational graphing, piecewise functions, and summer assignment. Okay, so the review from Algebra 2 stuff. So if you did not do the summer assignment, there were a few folks, or didn't get very far in it, I really would suggest you go back and finish that, even though you won't get credit on it. You're going to be tested on it. Yes, ma'am?
How do you know which section of the summer assignment that?
Whole thing. Whole thing. Even the geometry stuff. All of it's up for grabs. Okay? Odds are I'm not going to give you like a really, really hard adding rationals with different denominators. I don't think so. I mean, it might...
So is it says for the summer assignment is like
Yes, and your tests are always very, very similar to these guys, just not nearly as long. It's like usually 5 problems per. There might be more for factoring because factoring goes pretty quick. Okay? All right, so if you want to start the review, I'm going to put it up here. You can have it if you'd like. But right now I want you guys finishing your homework and doing your quiz corrections if you've got them. Okay? Go for it. Thank you all for being awesome and patient with me when I make all those sign mistakes.